Okay, hello again. So I will present about El Tatio geothermal field, which is located in northern Chile, in the Atacama Desert, which is one of the driest places in the world. It's the driest, in fact. So this site is considered as the largest and most diverse geothermal field in the southern hemisphere, and is the third in the world, with a lot of diverse thermal manifestations in the surface. So the location of this site, as I said before, is in the north of Chile, again in the Cordillera de los Andes, the Andes mountain range, but this time in the Andean Altiplano in the Atacama Desert. So it's one of the driest places of the world and over 4,000 meters of altitude. So it's a poly-extreme environment in many ways. So high altitude, very dry, very windy, and very high UV radiation. And because of the geothermal activity, it's one of the highest concentration in silica in waters in the world. So about the geological context, again, subduction. Chile is always related to subduction, but here the Cordillera de los Andes is higher and more and wider in the zone of the Altiplano. And here we have a geological map more detailed, where we can see the study area. The thermal manifestations of El Tatio are clustered in three areas: the lower basin, the middle basin, and the upper basin. The rocks of the area are mainly volcanic, ignimbrites, and glacial deposits. And the highest concentration of thermal manifestations are here in the upper basin. And here this white rock are the sinter deposits, the opaline silica, which is very, very characteristic of this place. And here we can see also the variety of thermal manifestations, including geysers, springs, mud pools, mud volcanoes, perpetual spouters, etc. In the global context, as I said before, is the largest geothermal field in the southern hemisphere and the third in the world, after Yellowstone and Valley of Geysers in Kamchatka. But one interesting thing is the highest of the major geothermal fields. So it's the lower boiling temperature by far, like 87 degrees Celsius. It's boiling the water. And in this place we have some of 8% of all of the geysers of the world, of the 1,000 in the planet. Here I made a recopilation of some of the thermal manifestations for you to see the geosite in reality. There's a lot of this type of structures related to the silica deposits, these mounds or molds, with some dry, some with liquid phases, and here we have the famous geysers. Some of them with different periodicities and with variations inside the geysers. These are the sinter deposit, the silica deposited in the area, which is very, very interesting from the astrobiological point of view. And all kind of thermal manifestation with very, very high temperature. And here we can see that this place is possible to visit it. It's a touristic place. Here are some measures of temperature, showing again the high temperature of the system and the different thermal manifestations, including perpetual spouters, geyser, hot springs, etc. And as I said before, even inside the geysers, there are very, very different type of geysers. Here are three different characterizations of geysers that are part of El Tatio, all connected to the deep reservoir. This reservoir have been measured with over 250 degrees Celsius. It's a very, very hot place. This is the conceptual model. There are dozens of this type of models in this place, but this is one of the most the current models. The water is percolated here in the high zone of the Cordillera and goes to the reservoir that, as I said before, with over 200 degrees. And is related to a fault here, and the thermal manifestations are controlled by the structures. Another aspect that is interesting about El Tatio are these, as I said before, the opaline silica structures that are very common with some found in Mars, especially in home plate, a geothermal system of Mars, where here the left images are from Mars and the right from El Tatio. In this publication, there's a lot of examples like this. I selected some, but there is a very interesting similarity between these two systems. Regarding scientific tradition, the first studies were related to the studies for industrial purposes. But this is the most famous geothermal geologist of Chile, Alfredo Lassen, that passed away this year, a couple of months ago, that proposed the conceptual model of the system that is still valid in the main points. Now, in the current research, is led by Carolina Muñoz Sáez, geologist from Chile, that here is inserting some pressure and temperature sensors inside the geysers to study in situ the area, and also installing seismic stations to measure the tremors and the fluid motion. And the other field of study that is very, very important now are the sinter deposits that are related to extremophile life. This is a paper published this year, and in 2022, I found at least 4 international papers about this topic, about the sinter deposits as an extremophile environment and possible analogous to early life in Earth and possible life in Mars. Another important question, another important issue here is that this place is inhabited by indigenous people since centuries. And El Tatio, the name, it means like the tears of our grandfather, or the grandfather crying. So they interpreted this as the tears of some entity. So it's very, very sacred place for them. And they are the managers of the tourism here. They manage the place. They are they are the guides of the tours, etc. So it's very connected with the local indigenous people, the Atacameños of el Altiplano Chileno. So, in summary, we have 2 main reasons for this place to be recognized as an IUGS Heritage Site. One is the geothermal system, which is huge, very varied, and very important in terms of the thermal manifestations. And the other is this new research area of astrobiology because of this polyextreme environment. So, before I finish, I want just to invite you to visit the other geosite of Chile that was not presented in this program, the site 66, Puquios of the Yamarazal Flat, which is related in some way with El Tatio because it's known as an extremophile environment for microbial mats. So this type of stromatolites that we have in the Atacama Desert, and it's also a hot topic of research now in Chile. So without more to say, muchas gracias, thank you, and you are invited to Chile.